Matrix multiplication. At the end of the last lecture, we discussed the inner product of two vectors, which is in a sense a way to multiply two vectors together. So now the question I'd like to address is, what does it mean to multiply two matrices together? And equally importantly, I'd like for us to understand why we might want to multiply two matrices together. So that's where I want to start off. So remember, the big idea behind matrices is that not only can they be viewed as an array of rows and columns, they can be viewed as machines that transform vectors. If a matrix has m rows and n columns, then we can multiply that matrix by a vector coming from r to the number of columns, so that would be n. And then once we perform the matrix multiplication by taking the appropriate linear combination of the columns of that matrix, we produce a new matrix, or a new vector that comes from r to the number of rows. So the big idea behind matrix multiplication addresses the issue of what would happen if we wanted to do something like that twice. So what if we had a diagram that looked like this? And the idea here says, well, maybe we start with a vector v that comes from Rn. We then hit it with the matrix B to take it into Rm. And then we hit that result with the matrix A to take it into RL here. So the idea is that if we have a situation that's configured like this, the question is, well, instead of going from V to B times V to A times B times V, what if we just cut out that middle step? Now, remember, diagrams that look like this aren't intimidating. They're really just fancy ways of communicating basic information about the matrices. When we say that B goes from Rn to Rm, that's really just a fancy way of saying that that matrix B has m rows and n columns. And when we say that A goes from Rm to Rl, this is just a fancy way of saying that A has L rows and m columns. So right away what we're seeing is that to even pose the question that we're starting with, which is what happens if we want to transform a vector twice like this, we immediately see that we need to be in a situation where one of our matrices has the same number of columns as the other one does rows. And in fact, if we skip this intermediate step, we should end up producing a new matrix, A times B, and that matrix should go from Rn, which is where we're starting with our original vector, and we skip that middle step and just end up in R to the L, which is saying whatever the formula is, which we will develop in a moment, whatever the formula is, when we take two matrices like this and multiply them together, well, apparently to take A times B requires that A has the same number of columns as B does rows. And then once we multiply these together, we should end up with an L by N matrix. That is, A times B should go from Rn to RL. Now, when I was a student, the way that I remembered this was if I want to take a matrix and multiply it by another matrix, if I just write down those dimensions side by side in the right order, the dimensions for the matrix on the left should be something by m, and then the matrix we're multiplying by on the right should be m by something. So that's the criteria we need in order to multiply two matrices together. And then once we do multiply those two matrices together, again with a formula that we'll develop in a moment, the result should be a new matrix. And the number of rows of the new matrix is the same as the number of rows of the matrix that we're multiplying on the left by. And the number of columns of the new matrix is the same as the number of columns of the matrix we're multiplying on the right by. So here we have a very well-motivated idea, albeit somewhat abstract. However, I want to make this idea a little bit more abstract so that we can appreciate some of the mechanics later. So with that being said, let's look at an example which is hopefully helpful here. So now the idea says, okay, well in this example, what if we wanted to take a matrix, in this case that's 3 by 4, and multiply it by a matrix that's 4 by 2? So again, I'm not even going to do the multiplication. I just want to understand whether or not it's possible to do this. And if we did multiply these two matrices together, what would the shape of the resulting matrix be? So the way that I like to sort this out in my head is I try to recreate the diagram we had from the previous slide. Remember, if we're taking A and multiplying by B, we're really trying to build a machine that sort of goes through B first and then through A. So that would mean that we could perhaps arrange our matrices in a diagram that looks like this. We want to go through B and then through A. And the question of whether or not that's possible is addressed by whether or not this dimension in the middle is the same. So in this case, B is a 4 by 2 matrix, which means it goes from R2 to R4. And A is a 3 by 4 matrix, which means it goes from R4 to R3. And here we see that that number in the middle really is the same. The number of columns of A is the same as the number of rows of B, so we are allowed to multiply these two matrices together. And how does the resulting matrix look, or what does the resulting matrix look like? Well, remember, what we're trying to do is build a new matrix that just skips this middle step. So we want a matrix that goes straight from R2 to R3, which means that when we multiply A and B together, we should produce a 3 by 2 matrix. So that's exactly what ends up happening when we take a matrix with this shape A and multiply it by a matrix with this shape B together. Is since A is 3 by 4 and B is 4 by 2, we multiply them together and we produce a new 3 by 2 matrix. Again, we haven't even said what the mechanics are, so we haven't even gone through how do we build these entries. For now, I just want us to understand when we're allowed to multiply two things together and what that multiplication produces when we do the multiplication. And again, maybe a less diagrammatic view on the matter is, well, we're taking a 3 by 4, we're multiplying by a 4 by 2, these middle numbers match up, so that's good. That means we can do it. And then what's the size of the new matrix? It's a 3 by 2 matrix. So we get a 3 by 2 matrix when we do this multiplication. Let's look at a different example. So these are actually the same shapes from the previous slide. On the previous slide, we took a 3 by 4 matrix and multiplied by a 4 by 2 and produced a 3 by 2 matrix. Well, what if we simply just swapped the order? So the question is, how does that change the situation? Well, remember, if we're trying to multiply B times A, what that is saying is that we want to build a machine that goes through A first and then through B. But this confronts us with an issue because A is a 3 by 4 matrix, so A goes from R4 to R3, and B is a 4 by 2 matrix, which means B goes from R2 to R4, but these numbers in the middle aren't matching up. This is a problem. And because those two numbers in the middle don't match up, that means that I cannot take this product. This product is not defined from our perspective. So such a product is impossible to take. So right away, what we're recognizing is we could have a situation where we could multiply two things in one order, but not the other order. We have to pay attention to this compatibility criteria. So in this case, B times A does not make sense, even though A times B does make sense.